So in today's lecture, we're going to talk about instantiating objects with hashes. So up until this point, I'm just going to copy some code over here, some boilerplate. So in this class address, when we initialize it, we're going to take in a first name, a last name, street 1, street 2, which can be like an apartment number or something like that, a city, a state, country, as well as a postal code. So if I wanted to create a new address, I would have to pass in all these parameters. Why did it not change? What happened? Well, why is that different? Oh, I know why. There we go. So I would need to take an address. I'd have to pass in a name, first name, and everything like that. Now let's just print this. Print address. Well, I'm invoking this print address, and it's going to do print in like a kind of a formatted way in which you would write when you're like sending a package or something. So let's run this. Hashes. See how it's kind of like that. But like up until this point, like what if I don't have like an apartment number and I just forget to leave it out and I run this code? It's gonna throw an error. And that's because when you're passing in parameters, when you're passing in parameters, you have to pass them in the order in which they are supposed to be passed in, the order in which they show up. So if I like forget to pass in one, or maybe I switch a couple around, if I switch it around, it'll still print out, but it's not correct with regards to the order in which it's supposed to go. So, and like also same with like, what if you mix up like the state or city, it's all gonna not meet the requirements. So if I swap the city and the state, and I run this code again, so I've got Jeremy Flores, the apartment, yes, an address, Washington, space Seattle, like it just doesn't make sense. So the order matters. But so we can, what if we only wanted to pass in an address? So an easier way to do this is if, which we're only going to pass in one parameter. We're going to pass in an address parameter. And now I'm just going to copy and paste this over here. If we translate this to a dictionary or hash, we only have to pass in the address info dictionary. Takes in one parameter, which is a hash. But now how do I assign these values to the correct instance variable? So yeah, it'd be address bracket first name. Then so I'm just gonna, instead of doing all that, I'm just gonna copy and paste. So this is essentially doing the same thing. So now you just kind of have to ensure that your variable contains all the correct items. So let's just run this code again and see what happens, see what we get back. Great. So this kind of will help us prevent having to ensure you have to pass in like a bunch of different parameters. But now, what if like city doesn't exist? Should I comment that out? Clear the terminal and run the code. Oh no. So it's missing a hash. So kind of running into kind of the same problem. But like here, if I mix up the city and the state, I put the state down here and run it, we still get the same thing. It doesn't matter the order in the dictionary. So that's a benefit of using dictionaries. But there's also a way we can, has anybody heard of, was it quargs? How do I, is it destructuring? Is that what it is? Let's see. Quargs in Python. Quargs is special syntax with this star and a function defines in Python used to pass in a keyworded, quarg, keyword argument. So we use the name quargs with a double star. The reason is because the double star allows us to pass in through key arguments. So what does that actually look like? So if I pass in keyword, like quargs, star quargs, this will actually be the dictionary. So if I do star, that's essentially doing the same thing. And what it actually is, what it's doing behind the code, behind the scenes, it's passing in first name equals Jeremy. Yeah, Jeremy, comma, last name equals Flores. So it's essentially doing that all the way down. So let's, oh, sorry, I meant not here. It's actually the quargs, the star dictionary value is essentially doing that all the way down. It's actually type passing first name equals Jeremy, last name equals Flores, street one, whatever. So let's run this and see what we get. Oh no. First name. Oh. So up here, instead of doing that, actually grabbing the address and first name, we can just do the first name. Where is that at? Instead of copying it all. Going back to our code. So it's actually looks like the original code. Let's run it again. Hopefully it works. Oh no. And Nick got an unexpected keyword argument. First name. I'm gonna address. Do I have to pass in anything? Does anybody see anything out of the ordinary? Item. I'm just gonna Google this because I don't know what it is. There's something. There's an error in my code somewhere. User Stack Overflow. This is 5 years ago. Do they use ***? Control quads. Is it actually? Do I actually have to use quads? The user's created. That doesn't make sense.
Are you supposed to star it in the init and not when you pass it in?
I want to look. Yes, that could be it.
So I think you have to, in the init, you have to do start.
Yes. Thank you. Yeah. So when I actually pass in, it has to know that it's going to take in a keyword value. And then let's run that. Thank you, Robert. Am I still getting one?
I think you have to do start quad.
Oh,
you actually use the word start quad. It's any number of keyword items.
Okay. You are correct. Thank you. Let's run that again. Line 3. I'm going to go back, and I think I actually do need to do that. Debugging is fun. Run that again. Name address is not defined. Address, yeah, address wouldn't be. Would be address info? No. I'm going to go back to here. Self.firstname equals address. Name address is not defined. So yeah, there's.
So that then allows you to simplify your code. So you for name in var or key comma value in vars self dot key equals value.
So
So you have to vars is a list, and then you can iterate over the list. So instead of having to pull out each thing in there, you can.
I can iterate through that.
Yeah.
Interesting. Let's see what that does. It's not defined. So I'm going to grab this. I copy this out. I just want to print this out and to see what happens. So I'm just going to initialize the address info. Maybe was it address info? Cool. So yeah, that's the keyword value.
And then initialize, you basically just have to say instead of printing, you have to say self dot or self bracket.
That whatever the key. Let's see if that works.
Value.
Will this work?
No, if you're iterating through it, you don't need to list off each thing.
Yeah.
That's the advantage of it.
Right.
So
we're just going to do
yeah.
key, right?
Yeah. And I think if you're doing brackets and you don't need
Yeah. See if that works. Let's print it. Oh, self dot. I think it'll be. Let's try that again. No, it doesn't work. Interesting. Well, I'm going to debug this a little more. Then we'll come back at 1 and go over it once I figure out what's going on. It's not super crucial that you know what, like, utilize quarks. It's just an easier way to pass in information. You can always just use a dictionary and pass in just the address info. So, but I'm going to debug this, and then at 1, we'll just have like a quick 10, 15 minutes thing just to go over quarks again. So for the remainder of today, you are working on 2 challenges. So we're officially done with algorithms and we're going into object-oriented programming. And the upcoming challenges today, tomorrow, and the rest of the week, there's going to be a little ambiguity as far as to how to solve it. You guys are going to solve it kind of your own way. Like, you guys are going to implement what you guys feel is the best solution, naturally. So we have 2 challenges today are apple trees and ice cream freezer. So apple trees. Implement the apple tree. You're going to be implementing 2 classes, apple tree and apple. So an apple tree has multiple apples when they grow. You're going to be implementing certain methods like aging a tree, and when you age a tree, certain things happen, like it grows. So the length of the tree, the height of the tree will grow. You can age the tree, so think about like when you initialize an apple tree, what instance variables are you going to have? You're going to have an age tree method, an isDead method, whether or not it's dead or not. And you can set parameters by checking of how old the tree is, of whether or not like the tree is dead. And if the tree is dead, will it continue to grow, or will it just stay at the same height? Or if it's dead, will it be able to produce more apples, create more class apple instances? So let's go into, so we have multiple files now. We have an apple file, where this is where your apple class is going to occur. And you also have an apple spec file as well. So we already kind of have like an initial test variable. Then we also have an apple tree class. And here it kind of already gives you the methods. Age of the tree, is the tree dead? Does it have any apples? And pick an apple. But now if you've also seen, we also have an apple tree spec file for tests, already tests written for you. So you can kind of do test-driven development, make sure these pass. Then we also have this apple tree runner file. So apple tree runner is what you will be running to simulate an apple tree growing. So it's going to call, let's see how it's calling an instance variable, or I'm sorry, it's instantiating a tree with the apple tree class. And then it's going to run the method, has any apples equals false. If it equals false, you're going to age the tree. So the tree is going to grow and stuff like that. While the tree is dead, the apple basket is there's an empty array. But while a tree has any apples, you're going to be able to append a tree. You're going to pick an apple, which is going to actually grab probably an apple instance and append it to the apple basket. So this is going to be a array of objects, of apple objects. And then, so you just essentially have to run this file to test your stuff, to simulate a tree growing and picking apples and stuff like that. And then it's going to print like a report. Tree age, height. So maybe your apple tree will have a height instance variable and an age instance variable. So that's the challenge, the first challenge today. And similarly with ice cream, let's go back to, so there's different releases, implement aging. Make sure you really read through this. Just implement this solution and then move on to like this one. Stuff like that. And then ice cream freezer, kind of the same thing. You're gonna have to design the structure. What kind of classes are you gonna use? What are you gonna have? You're gonna have an ice cream class maybe, and each ice cream class might have different flavors. And yeah. And then you're gonna also be able to test whether or not the ice cream is watery, almost ready, freezer burned. You just read through this. So, has anybody heard what dry is? Does anybody know what dry? DRY is an acronym for don't repeat like anything. Don't repeat yourself. So if you've already written the code, don't like write the code again. Like, don't do the same logic again. So don't repeat yourselves. So that's today. And you don't have to work in groups today or pairs today, but it's always highly encouraged. And then, yeah. And then be back at 1 and I'll review the quarbs. Try to debug what's going on there. All right. What questions do you have? Remote?
None at the moment.